Good morning, everybody. We have come back to this class. My name is Steve Bamishabi Samson. I'm the lead tutor for this course. We are still doing assembly language. This is section 1, course unit 2. The objective of the course still remains the same. Then the study section still remains the same. Then the learning outcome that is expected is for us to be able to define program counter and define instruction register, and at the same time to be able to do what? To state the function of instruction register. So how will be taking you through this concept? Programming counter and instruction register. When we say programming counter and instruction register, I don't know, maybe you understand what they mean by that, but let me quickly give you the brief definition of it. Program counter, known as PC, holds the address of the next instruction to be executed. The program counter is the one that holds the address of the next instruction. That is, when I say shut down, and I click shut down, the device in the system that will hold that instruction that I gave to the computer is the program counter. Why the instruction register? Listen up. Why the instruction register holds the encoded instruction upon fetching the instruction. The program counter does not know the instructions that I instructed or I initiated, but it will only keep the address. But instruction registers encoded the instruction. He encoded the instruction, that is coding the instruction, making it not exposable. So he encoded the instruction upon fetching the instruction. Once he collects the instruction, he will encode it. The program counter is incremental by one address value. It's incremental by one address value. 1, 2, 3, 4, 0, 1, 2. That's how program counter is. It's incremental by what? By one address value. So let's go. Basic of the program counter. A program counter is basically a specific purpose register in a computer. It contains the memory address or location of the instruction being executed by a CPU in the current time. As soon as the CPU finishes the execution of the current instruction, the program counter increases its value by what? By 1, and points to the next instruction to be executed by the OS. Listen now, we have said it in the introduction that it does it by incremental by 1. So as the processor carry out an instruction, execution of instructions, what the program counter does was that what did it do? The CPU, as soon as the CPU finished the correct instruction, the program counter increases its value by 1 and points to the next instruction to be executed by the operating system. The program counter now is a register that manages the memory address of the instruction to be executed. So what he does is that he serves as a register that manages the memory address of the instructions. All the instructions, he keeps them. That's what he does. The address specified by the PC will be what? Plus N bracket plus 1 for a 1-word instruction, and plus 2 for a 2-word instruction. Each time one instruction is executed, however, in the case of an interrupt instruction, the jump instruction address is what? Is stored. That is, when we interrupt a process, you move to another one. The jump address also, it will store it for people to know that he stopped a process and moved to another process. Are we together? So, the CPU reads the address where the instruction to be executed next is stored from the PC. So, for example, if 8 times 8020 address is stored in the PC, it means that the CPU is executing the instruction of the address of 0 times 8019. Then, if the address of 0 times 8020 is read from the PC, the address is what? The address is 0 times 8021 for reading the instruction to the executed next by the CPU is stored in the PC. That is program counter. The basic program counter, like I've said now, that this is just the simple diagram of a program counter: the address bus, the memory, the data bus, then the instruction registers, then the type of the PC, the program counter. Just a simple analogy of how it looks like. An instruction register is an element in the central processing unit of a computer or other devices that hold the program instruction that can be executed at the start of the next clock cycle as dictated by other part of the CPU. Other elements of the CPU, such as the instruction decoder, rely on the instruction register to hold this information so it can be decoded, resolved, and eventually executed. Generally, new instructions are given to the instruction register through the program counter, which serve as very similar purpose but can move ahead to the next instruction, while information the instruction register is holding is what? Executed. Once an instruction is referenced by the instruction register, it is passed to the instruction decoder. So the instruction can be converted into machine code. References to memory locations that might hold variables or other information are resolved, and that information is sometimes placed in other register. Finally, the actual instruction will be executed. Are you with me? The actual instruction will be what? Executed. During this time, the program counter will be incremented by the CPU to point to the next instruction that will be held by the instruction register. So the process can repeat until the entire program has been what? Executed. Be adding one, increment it, by that, so that until all the program is what? Executed. That is the concept behind that fundamental of instruction register. Then this now takes us to the workflow of program counter and instruction register. How did they flow? How did the work flow between these two? So a CPU contains the program counter and instruction register. It contains the two. At the beginning, the program counter is set to 0. Then the CPU starts its operation from 0. The first step is to fetch the instruction from the program memory. The fetching of the instruction is based on the memory location displayed by the program counter. The memory location that program counter has exposed to the CPU. It is that location that CPU will fetch the instruction from. Initially, it is 000. Hence, we will fetch the instruction with memory address 000 from the program memory. The CPU then goes into the decoding circle and executes the instruction. After completing the execution, the CPU is ready to fetch the next instruction. The program counter value is now incremented by what? By 1. It has moved from 0000 to 1. So, you can see the workflow there. Very, very direct and very straightforward. So the difference between the instruction register and program counter. Program counter holds the memory address of the next instruction to be executed. That is the PC. While IR holds the actual instruction. After fetching an instruction, the address value is incremented by 1. After fetching an instruction, they contain the next instruction. It contains the next instruction. A CPU locates the instruction in the memory from the program. Then a CPU decodes and executes the instruction from the instruction register. That's the difference between. So you need to be able to at least differentiate between the two. The conclusion of this course, this unit, is we have at least been able to explain what program counter does, and we told you that it holds the address of the next instruction, while the instruction register holds the encoded instruction. In summary, we have learned about the program counter, instruction register, their workflow, and difference between them. So, thank you for listening. We meet in the next class.